Hello. Current, electricity. Definition of current. Current is the rate of flow. Unit is coulomb per second or ampere. Coulomb or ampere is a very big unit. So smaller units are milliampere, microampere. 1 milliampere is 10 to the minus 3 ampere. 1 microampere is 10 to the minus. Sign convention. The direction of positive charge moving, the direction of current, and direction of negative charge moving is the opposite direction of current. Mass of electron 9.1 in 10 to the minus 31. Electron is very light, very less. Light particle can move easily comparison to positive negative ions. They are called immobile carriers. Very light particle mass is less, so it's called mobile carrier. Current mainly contributed by the electrons. There are two types of current, AC DC plus AC chapter alternate current. Here current due to immobile carriers ignored because they are having heavy mass, they hardly move, so we are ignoring in comparison to motion or current contributed by the electron. Here we are going to derive some relation. One is I current is equal to NaEBD. N is number density of free electrons or number of free electron per unit volume, and very large here for electrons in conductors. BD is drift velocity, very small due to the frequent collisions of electron with atoms, ions is very less, 10 to the minus 5 to 10 to the minus 3. That is thermal velocity, very large, roughly 10 to the 5 per second, roughly 100 km per second, is roughly 9 times more than the F velocity. Is the area cross section is the charge of electron minus 1.6 into 10 to the 19 coulomb. Resistivity is given by m upon n E square tau. Conductivity is reciprocal of resistivity n E square tau upon m. So conductivity is reciprocal of resistivity n is tau by m. Tau is the average relaxation time. Relaxation time means the average time between the two successive collisions, the average relaxation time by tau. Current density is denoted by J I upon A, and sigma E is the conductivity is the electrical field. Vector notation K is equal to sigma E, called vector form of Ohm's law. Now these relations are very important. कोई ना कोई relation अक्सर आता है. Repeated question. So we are going to derive above relations that we have discussed. Let us start. Here this is the arrangement. This is conductor of area of cross section A and length L. Here N is the number of electrons per unit volume, number density of electrons. If battery is not connected, in that case average velocity of electron in all directions being, so this we are getting no current. Average velocity of electron is zero, current is also so. Here u1 u2 when are the velocities of electron before battery connection, so average velocity here is 0 given by equation 1. But if connect the battery is V, then electrical field developed here given by voltage divided by length of the conductor. The direction of this electrical field is from positive terminal negative terminal. Considering electrons, force on electron is in the opposite direction of electrical field. Current we are getting in the direction of electrical field from positive to negative terminals for the battery connection. Now after battery connection, electrical field is E is equal to V divided by L. Direction of current from positive to negative, let's say here positive x. Or so all the electrons are moving effectively, not all the electrons are moving in the opposite direction of electrical field, but effectively, yes, they are moving in the opposite direction. Effectively, some are moving here and there, but if they are moving the opposite direction of electrical field, here the negative x-axis, current is flowing in along the positive x-axis, opposite direction. Now force on each electron is same, but charge is same, electrical field is same throughout. So we are getting the acceleration is force divided by mass. Force here is E divided by m. Numerical value is acceleration is equal to E by m. In vector notation, minus sign because electrons are moving opposite direction. So acceleration in opposite direction of applied field here. Because of this acceleration, velocity changes v1, v2, v3, vn are the velocities of electron after the battery connection, and the relaxation time for each electron, say number 1, tau 1, for electron tau 2, for electron 3, tau 3, and so on. So here v equal to u plus at. Well, so v1 is the velocity of electron number 1, v1 is the velocity of electron number 1 before battery connection, v1 is after battery connection, is same for all tau 1. Similarly, v2 for electron number 2 with electron number 3 and so on, vn is for electron number nth electron. If we add v1 plus v2 plus v3 plus vn, 1 plus u2 plus u1, and here a is common, tau 1 plus tau 2 tau 3 plus tau 1 divided by n. As per the equation 1, is the average velocity before battery connection, that is 0, and this left average velocity after battery connection is called drift velocity given by Vd, where a is common here, acceleration, and this is the average relaxation time given by tau. Average relaxation time for all electrons. So Vd is divided by, say, by putting the value of a acceleration here, e by m tau. So Vd drift velocity का formula मिल गया. So e by m tau. Now current here is total charge divided by total time. The conductor, n is the number of electron per unit volume multiplied by the volume area length. So NaL is the total number of electrons multiplied with charge of electron, the total charge. NaLe is the total charge on this conductor. Time is distance L divided by Vd drift velocity. L cancel हो गया. So the expression of the current here NaEd given by equation 3. Now we are putting the value of drift velocity by equation 2. We are putting the value here Vd e by m tau. Say here. Then we divide I current divided by area cross section, it will be the current density, and it is N equal to by M E, and this is called, at the bracket it is called conductivity. We derive after this. So J is equal to sigma E, the relation between the current density and the conductivity electric field. If we are writing it in the form of, say, vector, this is called vector form of given by this equation, but we are going to derive the presence of this conductivity. So this equation I is equal to NaE tau by m. This way N square tau divided by m. A and E we know electrical field is given by voltage difference of the battery and divided by L. It here, then we know I is equal to V upon R. We are writing it here like I equal to 1 upon R V. If we compare equation 4 and 5, then 1 upon R will be this, and the reciprocal will be R equal to M L upon N square tau by A. We know the relation between, say, R and the resistivity, resistance R, and this is the resistivity L by A. We compare equations and 7. This is resistivity given by this M upon N square tau. So by comparison from 7, at the expression of resistivity rho equal to M upon N square tau given by equation 8, and the reciprocal conductivity is 1 upon tau. So this is the expression of conductivity, and we are using this expression given by the equation 9 of conductivity here, this relation. This is conductivity. So we have derived equation 10, 11, with all the relations derived. Now we are going to say mobility. Mobility is mu equal to Vd upon E drift velocity. After cross multiplication, we are getting this relation. Drift velocity is equal to E is the electrical field mu is the A. Unit of mobility is meter square upon, say, volt. Now we know this relation rho equal to m upon n e square tau. M is the mass of electron, charge of electron, they are constant. Now resistivity, it means depends on n and tau. N is the number of electron per unit volume. Particular metal or material is also a constant. So we are taking for a particular metal or material, resistivity is inversely proportional to tau, and tau is the average relaxation time. Now we are discussing this for metal conductor. If we are increasing the temperature, frequent collision will be there because of increment in the temperature. It means increment in the heat energy, or say kinetic energy. Because of more kinetic energy, speed is more, so it is colliding, electron is colliding frequently with neighboring atoms and ions. Tau relaxation time decreases. By this relation, if relaxation time tau decreases, then resistivity will be increased. And by this relation, R is equal to rho L by A. If resistivity increases, resistance also increases. The reciprocal of resistivity is conductivity. The conductivity decreases. And conductance is 1 upon R. R is the resistance, G is the conductance, so R increases, must decrease. So this is the relation. Temperature increases, relaxation time decreases, resistivity and resistance increases, conductivity and conductance is. But for semiconductor, temperature increases, relaxation time decreases too. But despite this, resistivity and resistance decreases, conductivity and conductance increase. Why? It is just opposite of the case of a metal conductor. We know in semiconductor valence band and the conduction band, they are separated by called say energy gap. To increase the temperature, heat energy is more than the energy gap between valency conduction band. Then electrons are transferring from valency band to the conduction band. Electrons are available in valency band, but they are not conducting. But by getting the extra energy, they are transferred to conduction band. As they are in conduction band, they are being. Despite collision and collision with neighboring atoms ion, conductivity increases because now availability of electrons in the conduction band is much more than before. Despite collision, conductivity increases is the different case than the other. In conductor जो conductor है तो यहाँ पर बात करेंगे availability बढ़ रही है in the conduction band. If availability is more, despite collision, conductivity increases. Now this is we have seen conductor and semiconductor हमको learn करना. On the basis of this, बहुत सारे concepts हम कर हो जाएंगे. Like say, is the question board competitive many times in board. This question asked many times in board exam and the NEET JEE exam even. And very simple question. But if we know these relations here, then this is the graph given between voltage V and current I, and there are two graphs for different temperature. One from the graph, slope equal to what? Tan theta, voltage divided by current. The slope is more, V upon I means resistance is. For first case, this is the graph for temperature T1, theta 1 is more, so tan theta is more than tan theta 2. Slope means resistance, so R1 is more than R2. If temperature more, if the resistance is more, R1 is more than R2, for metal conductor, temperature is more than T1 is more than T2. For semiconductor उल्टा हो जाएगा, T1 is less than T2. Now for second question, here graph is given between I and V, and there are T3 and T4, there are two temperatures. Here slope given by I upon V, so we are not getting the resistance, we are getting the conductance I upon V. This is 1 upon R. जिसका स्लोप ज्यादा होगा तो रेजिस्टेंस कम हो जाएगा because it is decibel. So slope of 3 more than slope of 4. The resistance is less. R3 is less than R4, and for metal conductor R3 is less than R4, so T less than T4. For semiconductor उल्टा हो जाएगा, T3 is more than T. Now from the above relations, change in resistance depends on change in air, and this change in resistance depends on the initial value of resistance also. Initial value. Resistance initially is more than change in resistance is also for all. So on the basis of this relation, resistance at T temperature given by resistance at 0 degree temperature 1 plus alpha delta T. Delta T is the change in temperature and alpha is called temperature coefficient of resistance. Similarly, resistivity at T temperature is equal to resistivity at 0 temperature 1 plus beta delta T. Delta T is the change in temperature. It is defined as temperature coefficient of resistivity. Here In some books, alpha and beta denoted differently temperature coefficient resistance and temperature, but in some other books, alpha beta is same, like say of HCM also, they are same. Actually, they are same. So here, if you know, temperature increases for conductor, resistance increases, and semiconductor reverse. If temperature increases, resistance decreases and resistive. So this fact is metal conductor alpha beta is positive. It is positive by increment in resistance alpha delta T. This is positive. So resistance is 1 plus something added to resistance in case. If for semiconductor alpha beta is negative, by increase the temperature, because alpha is negative, so something decreases. So by increasing the temperature, resistance and resistivity, because alpha beta are negative in. So we must know, we learn it, alpha beta positive for metal and conductor, alpha beta negative for semiconductor. So this is the formula here, RT is equal to R naught 1 plus alpha delta T, or if we multiply like in the bracket, RT is equal to R naught plus R naught alpha delta. चले जाएंगे, RT minus R naught is equal to R naught alpha. So alpha can be written like RT minus R naught, that is called the change in resistance on R naught is the original resistance 1 by delta T. So it is delta R, change in resistance upon original resistance. This is called the relative change in resistance. So defined alpha, temperature coefficient of resistance, defined as relative change in the resistance per unit change in the temperature. Similarly, we can define it also. Change in resistivity, relative change in resistivity per unit change in the resistance. Now suppose here alpha is very less. As a very special case, if alpha is very less or negligible, means by this formula, if alpha is very less, almost zero, so by increment in the resistance, this quantity has become zero. So there is no change in the resistance. Means something very important. If alpha beta negligible, there is no change the resistance despite there is change in the temperature. Means resistance is not depending on the change in temperature. So resistance is same. This is called standard resistance. Standard resistance means if there is any change in the resistance, there is no change in the temperature, there is no change in the resistance, called standard resistance. There are some alloys. They are used to make the standard resistance. For example, there are some alloys like say manganese, Greca, Constantan, and nichrome. The ingredients of the manganese is 50% copper, 12% manganese, and 4% nickel. This manganese is alloy which is playing the important role of standard resistance. If we are using the manganese, there is no change in the resistance despite change in the temperature. Another alloy is a constantan, also called Eureka, 50% 5% copper and 45% nickel, and nichrome 80% nickel and 20% chromium. Now, usage of standard resistance, as we know, there is no change in the resistance despite change in the temperature. So they are using in the resistance box, lab, rheostat, wire resistance. They are used for verification of Ohm's law. In Ohm's law, the graph between V and I is what? Constant. So if resistance is changing, we cannot verify the law. In meter bridge wire also, in potentiometer wire also, we are using the general resistance wire like nichrome, constantine and vanillin. On the other hand, let us discuss this thermistor. It's also a very important device. Here temperature coefficient of positive and very high value means by the slight change in the temperature, there is drastic change in the resistance. The resistance rapidly change by the very small change in the air. They are often used in applications where a small change in temperature is clearly and reliably detected. There is a great change in the resistance and great change in the current also. You can easily detect the current. So they are using make the cloth addition paint, testy, and to protect the transformer, motor, generator, where by any means if there is change in the temperature rise can be detected and we can easily control by controlling the current. Even can stop the generator transformer, etc. The coil or armature can protect this from burning coil or arm. In some medicine, we have to keep that constant temperature where reactions are going on in cloth industry. It is very useful to maintain the temperature. Can easily control the current and also. Now, non-ohmic conductor. Ohmic conductor means Ohm's law followed. Non-ohmic conductor means Ohm's law is not. So there are some devices where Ohm's law is not followed. Graph between V and I is not the straight line, not passing in. Like say PN junction diode, semiconductor diode. A graph in forward biasing and reverse biasing is not a straight line but very small graph we are getting. In thyristor also, when in this part, it is the negative resistance. They are decreasing the voltage and current increasing. This is just reverse of this water voltmeter. After certain value of voltage, current start increasing. And this gallium arsenide, this alloy, semiconductor, here in this part, negative resistance. So here also Ohm's law is not it. In this part, Ohm's law is followed, but here is the reverse case. And this graph is not straight after this. So Ohm's law is not followed. These are called non-ohmic conductors. Come to Kirchhoff's law. There are two laws. In short, it is called KCL, Kirchhoff's current law, KVL, Kirchhoff's voltage law. Now, first of current law. In short, it is based on the conservation charge. So, here current at this junction, suppose there are many currents, I1, I2, I3, I4, I5. So, some currents are reaching to the junction and some are going away from the junction. As per the Kirchhoff current law, at any junction, algebraic sum with sign of the current is 0. Algebraic sum of the current is 0 means with sign. Suppose I1 approaching to junction, positive, going away from the junction, negative. So we can write it here. Algebraic sum of current is 0. I1 minus I2, I3 approaching positive, I4 going away, negative, positive. So like this equation, algebraic sum. Or I1, I3, I5 this side, I2 and I4 this side. So we can write the KCL this way also. At any junction, sum of all incoming current is equal to sum of all outgoing current. Second, Kirchhoff voltage law. As per the Kirchhoff voltage law, in any closed circuit must be closed. In any closed circuit, path or loop, total voltage drop or total voltage rise is 0. Total voltage drop or rise is 0. What is the meaning of drop or rise? Let us discuss this. Suppose we are moving from A to B, the battery or cell, positive terminal, negative terminal. PAB means A to B is drop, higher to lower, it is called voltage drop. Let us say as per NCERT, voltage drop is negative. So higher to lower voltage, high voltage to low voltage, or we are getting say drop, low to high it is voltage rise. As per NCERT, drop is negative, rise is positive. Otherwise also we can take, we are getting the same result. Some other works and also voltage drop is positive and rise is negative. There's no problem. We'll get the same result. Now, Suppose there is a wire, current is flowing from D से C की तरफ current है, and we are getting the current from higher voltage to lower voltage. So from D to C drop, VDC is voltage drop. In the direction of current we are getting the drop, in the opposite direction of current we are getting the, याद रखना, voltage drop means in the direction of current drop, in the opposite direction is rise. Sign convention depends on your choice. Don't confuse. You can take drop negative, rise positive, otherwise also we get. But one convention yellow. So true, gold also, everywhere. So we are taking drop is negative, rise. But here we'll consider here drop negative, rise by. Say that I discuss the cell or a battery. That is the combination of two or more cells. Combination of two or more cells. What is cell here? That I discuss in a container. There are two electrodes of copper. Let's say dilute sulfuric acid. So the dilution of sulfuric acid here coming say ion, H ion and sulfate ions like this, and zinc rod, it is say leaving behind the zinc rod two electrons and zinc positive ion coming in. In the solution, zinc ion is there and sulfate ion is there. Coming the sulfate, which is the passive material, means cannot convert in zinc and acid. So this is the use and throw policy. But passive material cannot be converted into active material like zinc and acid. So here hydrogen ion goes to the copper rod, taking electron becomes hydrogen atom will become hydrogen gas, it go out from the. So here cathode is called anode, zinc is called but for outside circuit, copper is anode, zinc is cathode. Inside this cell, zinc is anode, copper is. It depends on the direction of current. Outside the circuit, current is flowing from copper to zinc. Electrons are moving in the opposite direction from zinc to copper. Current we are getting from copper to zinc. So from outside this cell, outside the circuit in the low resistance or bulb, current is flowing from copper to zinc. So it is node. Inside we are getting the current not because of the flow of electrons but because of the flow of ions. As we can see here, positive charge zinc ion and hydrogen ion moving from zinc to sulfate ion moving the opposite direction towards earth. So current we are getting from zinc rod to cathode inside the cell. So zinc rod is called anode, copper is cathode. It depends on decided by the direction of करंट, यानी कि अब फिजिक्स में सब ये एनोड है कैथोड और केमिस्ट्री में उल्टा हो जाएगा, तो नेगेटिव हो गया, ये जिंक रॉड को बोलेंगे एनोड. फिजिक्स में ऊपर जाएगी करंट तो ये कॉपर एनोड, जिंक. It is decided by the flow. There must not be any confusion here. Decided by the current. Outside the cell, copper anode, cathode, and inside the cell, copper cathode. Now this region decided by the current. Now let us discuss this cell or battery. H and B are the terminals where this is the electromotive force EMF and R is the internal resistance. The internal resistance of the cell depends on many factors like say electrodes and electrolyte. In electrode, internal resistance depends on nature, area of cross section, gap between the electrodes, electrolyte, the nature of electrolyte, concentration of acid, and temperature of the electrolyte. There are 6 factors, 3 from electrolyte. Now, discussing this here. First case, when the battery in battery discharging, say for a mobile also, we are using the mobile, battery of the mobile is discharging to the load resistance, that is the external resistance. So we are going to find the relation between the terminal voltage VAB and VKB, that is the terminal voltage of cell. R is the internal resistance, is the EMF, electromotive. Say, within the closed circuit, current is flowing from positive terminal to negative terminal in the outside circuit. So in anti-clockwise direction, we are getting the current. Now, applying the Kirchhoff voltage law from A to B. A to B is what? Drop. So drop is minus AB. And from A to C, also drop from higher voltage. Lower voltage also drop negative. But if we are moving the opposite direction, C to B, we are getting the voltage rise of positive. यहाँ पे हमने minus कॉमन ले लिया. So we can write here VAB is equal to E minus IR. If we are taking VAB, drop and rise, even then we are getting the same result. Minus ही तो कॉमन लेना. So either you take drop negative or drop positive, 100% there is problem. But as per NCERT we are always taking drop negative, rise positive. कभी यार क्वेश्चन में डेटा लिखने से पर कट गए. मैं खुद देखा है बोर्ड में. Why we are not following the result सेम आ रहा है फिर भी बोर्ड की बात अलग. तो we are there प्रॉब्लम ही नहीं है. चाहे नेगेटिव लो ड्रॉप को चाहे पॉजिटिव, एनसीईआरटी के हिसाब से हम आपको नेगेटिव, तो नो प्रॉब्लम, रिजल्ट तो सेम ही आएगा. तो बाय इक्वेशन 1 VAB इज लेस देन MF एंड VAB इज इक्वल टू EMF, करंट इज जीरो. करंट जीरो होगा तो ये टर्म हट गया. VAB इज इक्वल टू E. नाउ वी आर गोइंग टू डिफाइन द MF. EMF इज द ओपन सर्किट वोल्टेज. ओपन सर्किट में VAB A और B के बीच में टर्मिनल वोल्टेज है, दैट इज EMF. इफ सर्किट इज ओपन, current flowing zero. So defining the EMF of a cell is open circuit voltage. The open circuit voltage, or there is no current drawn from the battery when cell is not in. So EMF is the maximum voltage and there is no current flowing. करंट फ्लोइंग है तो ये भी कम हो जाएगा. नाउ इन केस ऑफ सपोज बैटरी डिस्चार्ज, यू हैव टू charge it by the suitable charger. Suitable means charger voltage must be more than battery voltage. That case in closed circuit, battery की tendency होगी say is the positive to negative in the anti-clockwise direction, but charger is dominating more voltage charger than battery. So ultimately charger की current में ही डायरेक्शन में करंट, यानी ये A to B करंट की डायरेक्शन होगी. डिस्चार्जिंग उल्टा है, यहाँ पर एंटी क्लॉकवाइज करंट है, यहाँ क्लॉकवाइज करंट. तो चार्जर टू A to B करंट, डायरेक्शन ऑफ करंट. नाउ इन ओपन सर्किट वोल्टेज A to B, वी आर राइटिंग द किरचॉफ वोल्टेज लॉ. तो A to B drop negative, A to positive to negative drop in the direction of current C to pin drop, taking the minus common. Again ये drop लिखा था नेगेटिव, अगर इसे माइनस कॉमन लेके लिखते हैं फिर ये भी ड्रॉप वही रिलेशन हमको. साइन कन्वेंशन इज 8%. Your choice in pattern board, follow the 39. Now here from the equation 2, VAB is more than E, terminal voltage more than the EMF in case of charging of a cell or battery, and VAB is equal to if current is zero. करंट जीरो हो जाएगा तो फिर से वही डेफिनेशन हो जाएगी. टर्मिनल वोल्टेज इज द ओपन सर्किट वोल्टेज, है वो चार्जिंग की बात करो या डिस्चार्ज, तो करंट ही जीरो है, इस बात की चार्जिंग. So open circuit voltage called EMF of a cell. Now suppose there are many cells connected like in battery. Suppose here series combination of cells. There are n cells connected in series, and the overall this terminal finally connected to the external resistance load. Hence current direction will be from positive to negative overall. So current is given by the total voltage divided by the total voltage will be कम हो जाएगा. पॉजिटिव नेगेटिव टर्मिनल लगे हुए हैं तो टोटल वोल्टेज विल बी NE अपन टोटल रेजिस्टेंस 30 होती नहीं, तो R plus NR. If external resistance much more than NR can be neglected, then it will be NE upon R. यानी एक रेजिस्टेंस जो दे रहा है करंट E by R, N cells will be NE by R. So this way, if R is much more than NR, beneficial here connect them in parallel combinations of cells. Identical n cells are there in parallel voltage remain the same. Current will be total voltage divided by the total resistance. Voltage is only and resistance is total plus effective total. These resistance internal resistances are connected in parallel. The formula here is 1 upon R. Effective will be 1 upon R1 plus 1 upon R2 plus 1 upon n times, and R is same, so it will be N by R. Reciprocal here is R by N put here. So current will be E upon R plus R by N calcium. So N ऊपर चला जाएगा. I is equal to NE upon NR plus R given by equation 3. Here is the internal resistance much more than the external, इसको अवॉइड कर देंगे. NE by R, एक सेल जो करंट दे रहा है पैरेलल में हमको N टाइम करंट मिलेगा, तो इट इज बेनिफिशियल. यानी हम पैरेलल में जाएंगे, अगर एक्सटर्नल रेजिस्टेंस कम है इंटरनल ज्यादा है तो पैरेलल कॉम्बिनेशन, और अगर एक्सटर्नल रेजिस्टेंस ज्यादा है इंटरनल कम है तो सीरीज कॉम्बिनेशन. हर बार हमको करंट कम देते. नाउ इन बोर्ड वेरी इंपॉर्टेंट एग्जाम में आता है, कई बार देखा है क्वेश्चन और डेरिवेशन कॉम्पिटिटिव एग्जाम में कभी नहीं आ रहा, इन बोर्ड में क्वेश्चन न्यूमेरिकल एंड थ्योरी दोनों आ जाती है. Let us discuss the mixed grouping or mixed combination of cells. Here all the cells are identical and cells in series. This is one group, such m groups are connected, so this connection is called the mixing. Total number of cells एक सीरीज में है and number of groups में mn. Total number of cells will be m into n. Current is given by total voltage divided by total resistance. एक सीरीज ग्रुप का n ही है तो पैरेलल में सेम रहता है, तो n ही रह जाएगा. इफेक्टिव वोल्टेज NE अपन रेजिस्टेंस इंटरनल प्लस इफेक्टिव इंटरनल रेजिस्टेंस कॉम्बिनेशन है. एक सीरीज ग्रुप में है NR, तो 1/R effective will be 1/NR plus 1/NR plus 1/NR. How many times? This is the number of groups. So m times m/NR. So R effective will be reciprocal NR/m. Now putting the value of R effective NR by M in equation 1, we are getting I equal to NE/R plus this NR by M. Taking LCM, M ऊपर चला जाएगा. So MNE/MR plus NR given by equation 3. Now we know the identity in math A plus B equal to under root bracket A minus B whole square plus 4AB. Let us use this identity here. Let us say taking say A is equal to what? MR, and let B is equal to NR here. So MR plus NR can be written with this identity A minus B, and MR minus NR whole square plus 4MR NR. Current will be maximum if the denominator is minimum. Denominator minimum means this quantity is 0. So MR minus NR is 0. So MR is equal to NR, or R is equal to NR by M. R means total external resistance R, and this is the NR by M is total effective internal resistance. If they are equal, we are getting the maximum current and maximum power. So this is the condition. Total external resistance is equal to total internal resistance. This condition will give you maximum resistance, the load or external resistance drawn from the battery. Sometimes it is called maximum power transfer theorem. Maximum current and maximum power transfer theorem. What is this? This is the simple condition. Total external resistance is equal internal resistance. For maximum current, this part is 0, will become MNE/under root 4MR/NR. If we are using this relation, MR is equal to NR, R को MR से रिप्लेस कर देंगे, लाइक तो ब्रैकेट के बाहर अंडर रूट के बाहर आ जाएगा, अंडर रूट के बाहर 2MR, M कैंसिल. वी आर गेटिंग I maximum is equal to NE/2R. MR की जगह NR रख देंगे, I maximum will be ME/2. Both are same. This is in terms of N and capital R. This is small m and small m and small r. Small r is the internal resistance. Now very important also, this is also a repeated question in board and competitive examination. When the cells are not identical, they are different cells, it means EMF is also different, internal resistance also different, and they are connected like in parallel. Then we have to find out the effective equivalent EMF and equivalent internal resistance if the different cells are connected. Let us say this is the circuit. Here there are two cells E1, E2, R1, R2 internal resistance connected to the external resistance. Or let us say current I1 is drawing from the battery number 1, cell number 1, and I2 is the current from battery, and this is the total resistance flowing through the external resistance. At this junction, suppose we apply Kirchhoff current law, then I is equal to I1 plus I2. Outgoing current is equal to sum of incoming current. So equation 1, external current, total current I is equal to I1 plus I2. एक्सटर्नल रेजिस्टेंस में जा रही करंट वो है I. यहाँ से I1 I2 आ रही है from that is 2. Now applying the Kirchhoff voltage law in the closed path A, B, C, D, H, A. This is the closed path. Now from higher voltage to lower voltage, A to B drop minus E1. In the opposite direction of current here, I1 R1 positive opposite direction of current. So rise. Here also I के against में जा रहे हैं opposite में, so IR. This is also rise. Now it can be written as E1 is equal to IR plus I1 R1 equation 2. Similarly for this path. Here F E, D, G, H in A, F. So this is the path F, E, D, H, F. Here higher to lower, drop minus E2, opposite directional current, I2R2 rise, IR rise, E2 can be written IR plus I2R2 equation D. Now if we multiply equation 2 by R2 and multiply equation 3 with R1 and then we add, we are getting even R2 मल्टीप्लाई कर दिया इसको आई आर आर टू प्लस ये आई आर वन आर टू सिमिलरली तो आर वन से किया ई टू आर वन आई आर वन प्लस आई टू आर वन आर टू क्वेश्चन 4 and 5 को ऐड कर तो ई वन आर टू प्लस ई टू आर वन आई आर कॉमन आर वन प्लस आर वन आर टू कॉमन आई वन प्लस आई टू इट कैन बी रिटन एज आई यूजिंग इक्वेशन 1 तो हियर तो हमने पूरे टर्म को आर वन प्लस आर टू से हर एक तो इस टर्म को डिवाइड कर दिया लाइक कैंसिल हो जाएगा इसमें यहाँ पे मिलेगा आर वन आर टू अपन आर वन प्लस आर टू यहाँ ये कैंसिल होके आई कॉमन ले लिया हमने तो आर प्लस आर वन आर टू अपन डिवाइड करके आर वन एंड हियर डिवाइड कर दिया आर वन प्लस नाउ दिस द इक्विवेलेंट सर्किट ऑफ कॉम्बिनेशन लाइक दिस हियर दोनों पूरे कॉम्बिनेशन का ईएमएफ इक्विवेलेंट है एंड इनका इंटरनल रेजिस्टेंस आर इक्विवेलेंट and this the external resistance current is I. Suppose here we write E equivalent is equal to IR. I the total resistance given by equation 7. Compare equation 6 and equation 7. I R के कैंसिल हो गया कंपेयर करके R equivalent will be this and E equivalent will be this. So E equivalent will be E1 R2 plus E2 R1 upon R1 plus R2 and R equivalent will be R1 R2 upon R1 plus R2 or 1 upon R effective is equal to 1 upon R1 plus 1. So these are the effective or equivalent EMF and equivalent resistance. Let's suppose you divide E equivalent divided by R equivalent this by this. Here R1 plus R2 कैंसिल हो गया तो अगर हमने E1 R2 को R1 R2 से डिवाइड किया तो R2 कैंसिल हो जाएगा फिर R1 कैंसिल हो जाएगा सो E1 upon R1 plus E2 upon R2 ऐसे भी लिख सकते इन जनरल देयर आर मेनी सेल्स कनेक्टेड तो जनरलाइज कर देंगे हम लोग E equivalent upon R equivalent is equal to E1 upon R1 upon R2 plus E3 upon R3 plus E4 upon R4 and so on for many cells, different cells. And R equivalent in parallel 1 upon R1 plus 1 upon R2 plus 1 upon R3 plus 1 upon R4 like. As a very special case, see, the same question is coming but polarities of E1 E2 are opposite. They are not supporting like in previous cases. Say E1 and E2 दोनों पॉजिटिव टर्मिनल एक ही जगह दोनों नेगेटिव है बट यहाँ पर अपोजिट E1 इस जगह पॉजिटिव यहाँ पे E2 की नेगेटिव अपोजिट पोलैरिटी so opposite polarity because of opposite polarity minus sign comes here so equivalent will be E1 R2 minus E2 R1 upon R1 plus R2 and polarity इसमें resistance there is no change there is no minus comes here ये तो सेम ही रहेगा और E equivalent will be upon R equivalent will be E1 upon R1 या माइनस आ जाएगा because of polarity and यहाँ पे कोई polarity का चांस नहीं सेंस में many cells के लिए जो पॉजिटिव लिखो जो नेगेटिव लिख लो in this general equation and में कोई R equivalent now come to Wheatstone bridge. Here, the scientist Wheatstone, he has arranged 4 resistances in the form of a bridge shown in the figure. P, Q, R, S for resistance. The form of a bridge. Across the two ends of this bridge, a battery is connected. Across the two ends, sensitive galvanometer is connected. The total current I divided into say I1 and I2. Here current Ig is passing through the galvanometer. The remaining current here Cb is I1 minus Ig and here both are added up. So we are getting in this arm dB in resistance as I1 plus I2 plus Ig. Suppose by changing the resistances, a situation, very special situation comes when there is no difference of voltage Vc and Vd. VCD difference is 0. It means potential of C and potential of D, they are equal. If there is no potential difference, current will be voltage divided by the resistance of galvanometer. But there is no voltage difference, so there is no current Ig 0. It is called null position or the balance condition of voltage. In the balance condition, we are applying the Kirchhoff voltage law in the path closed path A, C, A and B, C, B, C. Here in this path A, C, D, A में Kirchhoff voltage law. In the direction of current I1 or I1P drop the direction of current. Here it is 0. from D to A in the opposite direction current, so rise I2 resistance R. It will give you I1 P equal to I2 R given by equation 1. Similarly in this path C B D IG 0 हो गया, तो यहाँ पे लिखेंगे voltage drop in the direction of current here I1 Q, that is drop, यहाँ पे ये 0 हो गया IG, तो I2 S in the opposite direction, so rise S, यहाँ पे तो जाई है, it will give you I1 Q is equal to I2 S given by equation 2. If we divide equation 1 by equation 2, we are getting I1 P, I1 Q, I2 S, R I2 S, I1 I2 cancel, okay, तो मिल गई condition P by Q is equal to R by S. It is called null condition or the balance condition of bridge. Meter bridge, now that is not in the CBSE syllabus, but question may come in board also, in competitive examination also, numerical problems may. So we are going just discussing the meter bridge, numerical point of view से discuss करना. Let us say this is the practical Wheatstone bridge. This is the resistance R S and this resistance of wire AJ, resistance like P, and resistance of JB wire is like resistance Q. So this is the same bridge. Practically, you are as for resistance battery connected and sensitive galvanometer connected. Practically, we have connected page is called practical Wheatstone bridge like this. So across these two terminals, battery connected across these two terminals here, and galvanometer. This is sliding contact called say jockey. This is sliding over the AB wire, and AB wire specific resistance of AB wire is resistance per unit length of this wire. These are the copper strips, almost no resistance. Present correction में resistance error कम से कम आए, so we are taking the copper conductor है, ले लिया ज्यादा एरिया तो और resistance कम हो गया. Here by sliding contacts के over the wire, a situation come when galvanometer current is 0, null position or balance condition. Again we are using the same condition of balance condition of Wheatstone with this P by Q equal to R by S here. So R upon S, R is the known resistance of resistance box, S is the unknown resistance, P means resistance of AJ wire, L into R resistance is unit length multiplied by the length is P, and here 100 minus L length multiplied by R is the resistance Q. R cancel, okay, L upon 100 minus L. This way unknown resistance can be found 100 minus L upon L into R. By knowing the resistance of R resistance box, the known resistance, and the balancing length L from the left hand, we are using this relation and we can find out the unknown resistance. Now heating effect. Heating effect of current, it will give you heat, so we are using in electrical press, bulbs, oven, heater, geyser, etc. The energy is given as power into time. Power is defined as work done divided by time or energy divided by time. Power is V into I, voltage current in T, so this is the energy. R V is equal to IR say I square R, and T also T square R into T also. अगर T को हटा दें, power will be energy divided by time, यानी T हटा दिया ऐसे, तो power will be VI I square R and V upon R. तो T से मल्टीप्लाई करेंगे तो एनर्जी नहीं रख मल्टीप्लाई नहीं किया, तो दिस इज इलेक्ट्रिकल एनर्जी पावर इनटू टाइम. पावर को हमने किलोवाट में लिया है, T को आवर्स में लिया, देन 1 यूनिट ऑफ इलेक्ट्रिकल एनर्जी इज 1 किलोवाट आवर. 1 किलोवाट को हमने वाट में चेंज किया, 1000 वाट, और आवर को सेकंड में इंटू 6 मल्टीप्लाई करके ये आ गया. सो 1 किलोवाट आवर और 1 यूनिट ऑफ इलेक्ट्रिसिटी गिवन एज 3.6 और 6 इज द रिलेशन ऑफ 1 unit of electricity. This is 3.6.